All right, so basically, when you have inverse relations, right, it's when for one relation, like if you have any coordinates like a comma b, you can also have the inverse b comma a, right? So for example, if one equation maps out certain coordinates, right? 2 comma 3, 3 comma 4, and so on, then you can also reverse them, and you can also have like 3 comma 2, 4 comma 3, and so on. So if that's the premise, right? If that's the premise that the x and the y are basically switching, right? You're swapping x and y, then everything else follows along consistently with that. So take a look at what we have here. Here we have y equals x squared minus 4. That's a parabola, right? We've seen those parabolas before. That's this one here, y equals x squared minus 4. That's that blue parabola, all right? And look at some of the coordinates on that parabola. Somebody went in and made a chart for us. So when x is negative 3, y is 5. When x is negative 2, y is 0. 1 comma negative 3, and so on and so forth, right? Now, you also have another equation here, this one. X is equal to y squared minus 4. It has, they look similar, but the x's and the y's are switched and stuff, right? Like they're different. The graph of that one is this red one right here. I'm sorry, the green one, sorry. It's that green one right there. And so let's compare the coordinates. Where we had negative 3 comma 5 here, on this one I have the, the reverse, 5 comma negative 3, right? So if I take another one, 0 comma negative 4, it's swapped, negative 4 comma 0, right? And you can do that for every single one of the coordinates, all right? Okay, another thing happens. So that's as far as coordinates is concerned. When you do this, another thing happens. Remember domain and range, right? For domain, did we always look on the x-axis or the y-axis? The x-axis, right? And for the range, we looked at the y-axis, right? So when you go from a relation, when you go from one equation to its inverse, because the x's and the y's are now going to swap, the domain and the range are also going to swap, okay? So take a look. If you have an inverse of a relation, this is the notation that we usually use, right? Now, when we're talking about functions, and we'll get to that in a little bit, okay? If you have f of x, and suppose that has an inverse function, f inverse of x, okay? So to the power of minus 1, that means inverse. Okay. F of x has a domain and a range, right? We've been finding those like since the beginning of the year. When you switch to the inverse, the domain becomes the range, and the range becomes the domain. They literally just swap. Okay? We're going to do a little bit more of that in a little bit. Okay. Now, we can also take a look at inverses when it comes to graphs. All right? So take a look. If you have an inverse, do you see the blue and the green? If you draw this red line here, this is y equals x, right? Everybody's favorite line to draw, right? Y equals x. If you draw y equals x, then every single coordinate on the blue will have a mirror image along y equals x. So for example, let's take a point here. If you take this point, what's this point right here? This is x is 2, y is 0, right? Okay, on the green, the corresponding point will be 0, 2. And if you notice, that's just mirrored along that line y equals x, that red line. Okay? So any point here, you can mirror it on that point and it'll become part of the red one, all right? The green one. We're going to do a little bit more of this later on. Okay. Now, let's talk about when an inverse has an inverse, when a function has an inverse function. Okay? Because remember the vertical line test? What does the vertical line test do? It tests if something is a what? A function. Now, similarly, we have what we call the horizontal line test. The horizontal line test is similar. If you have a graph, you can draw a series of horizontal lines. And if it passes the horizontal line test, it means if each of the horizontal lines crosses the graph only one time, that means the inverse of that blue will be a function. Okay? So, if passes horizontal line test, it means inverse is a function. Okay? All right. So let's take a look at some of these and see if these have inverse functions. So look at what this says. Graph each function using a graphing calculator. Apply the horizontal line test to see whether its inverse function exists. So take a look. Let me graph that first one. Here, let's graph this one. So it's 4x squared, yeah, plus 4x plus 1. You're going to do the horizontal line test. So take a look here. This is the graph right here, right? If you do a horizontal line test, does it pass? No, it does not pass. That means it does not have an inverse function. So you say no, it does not have an inverse function. Because if you draw a series of horizontal lines here, it will pass the graph at more than one place. Yeah. The next one, x to the 5. So let's do the next one. Delete this. So x to the 5 plus x cubed. Actually, I had these graphed ahead of time and then I had to restart my calculator, so they went away. Plus x cubed minus 1. Okay, so what do you think? Does this pass the horizontal line test? Yes. Yes, it passes the horizontal line test. All that means is now, when we find the inverse of it, it will be a function. That's all it means. Okay? Okay. So, just like we said before, when you find the inverse function of something, the domain and range will switch. So for example, the domain of f will become the range of the other one and vice versa. So for this function, f of x is equal to root x plus 2, I want us to find the domain and range of the function itself, right? So this is what we've been doing since the beginning of time, right? So what would you say is the domain of this? This is a square root. What are we going to do with the x plus 2? Greater than or equal to 0. So x is greater than or equal to negative 2. So the domain is negative 2 to infinity, like this, right? Okay. The range, right? We can look at it in a couple of different ways. When I graph this, what will it look like? This. Okay? Let me graph it on the calculator. Let's graph it. X plus 2. What's the range of it? 0 to infinity. Okay? So here, there is nothing new It's the same as what we've been doing before, yeah? Now, I want to find the domain and range of f inverse of x. It's just opposite. So this, which was the domain, will become the range. And this will become the domain. Okay? So, Well, it kind of is. If you look at the bigger implications of it, if you look at the bigger implications of it, of where all this applies, and right now, you're just learning the beginnings of it, and then learning the ABCs, and then when you learn to read all those wonderful novels, it's oh my God, this is why I learned all that. The implications of it are so wonderful. So okay. Now, how to find an inverse function. Okay, this you probably have seen last year in algebra 2, but it's very quick. It'll leave your mind very quickly. But once we start doing it, I think you'll remember. So, to find an inverse function, first you have to determine whether it even has an inverse, right? By doing the horizontal line test. Then, in the equation, you're going to replace f of x with y. Then, interchange x and y. Solve for y. And replace with f inverse. And then we have to state any restrictions if there are any. Okay? Well, let's do one, and then you'll see, we'll tie it in. Okay, so let's go step by step. First, determine if it has an inverse function. Now, let's see if we could do this mentally. This is a square root graph, right? And what do square root graphs look like? This. Would it pass the horizontal line test? Yes. It would, so it does have an inverse. Okay, now, the next step is replace f of x with y, which we can do. And interchange x and y, right? So I'm going to do x equal the square root of y plus 6. Okay? Make sense? Now we need to solve for y. That's number 3. Solve for y. Okay, so to solve for y, I need to square both sides. So I get x squared is y plus 6. Subtract 6. So I get x squared minus 6 is equal to y. But now I can't leave it as y because this is the inverse function, right? So I need to replace it, and I need to say f inverse of x is equal to x squared minus 6. Okay? All right. Well, this is until the second to the last step. Then it says state any restrictions if there are any. So let's take a look at what we've done. What we had was root x minus 6. That was the graph. Okay? When I found the f inverse, what kind of graph does that give me? What is it? Oh, so is it it's a square. Is it it's a parabola, right? So when I graph that parabola, it looks like this. Okay, now look. You see how this only had one arm, right? This has twice the graph basically, right? It has one arm on this side and another one on this side, right? So what that means is I've added now to my function. I've added to my graph, right? That means I need to take away part of it. So this one here only corresponds to this one. Because, remember what we said? It has to be like the mirror image of this one, right? Mirror image of this one, okay? So now, we need to write the domain of this. What's the domain of this? It's the range of the one before, right? So we need to write the domain of this. What is the domain? It starts from 0 and goes to infinity. So I say the domain is from 0 to infinity.
That's the domain after the range.
Of this. Yeah, so you can look at it two ways. One, you can say this one, let me erase this. Okay, so do you see how we had the y equals x before? This has to be a mirror image. Okay, so it could only be one arm of it. It can't be two arms. Okay? All right. Let's do another one. This one is a cubic graph. What does a cubic graph look like? It's like a wiggle like this, right? And if you're not sure, you could just look at it on your calculator. Would that pass the vertical line, the horizontal line test? Yes, it would, right? It would. So it does have an inverse function. So let's find the inverse. Y equals negative x cubed plus 4. All you need is the restriction on the domain. Yeah. So here, x equals negative y cubed plus 4. Bring 4 to the other side. Okay. Let's divide everything by negative 1. Because I have a negative y cubed and I'm trying to solve for y. So I have negative x plus 4 is equal to y cubed. You want to divide by a negative to make this negative go away because you're solving for y. You want to get y alone. Now, here we're going to take a cube root of everything. Okay? You take the same root as the exponent. So y is equal to the cube root of negative x plus 4. Right. So, but before we get there, you never leave it as y. You always want to replace it as f inverse of x. That could be a reason for points off, right? So make sure you at least get that point right there. Now, look at this here. Do you see how the domain and range of the initial function was all real numbers? That means for the inverse, we don't have to bother with restrictions, right? So there are no restrictions on this. Okay? All right. So no need for restrictions. Okay. So usually when you're going from a square root to a square, that's where the restrictions are going to come in. Okay? For the other ones, if, for example, for this one, because the domain and range were all real numbers, then there is no restriction that you need to worry about. The reason why we need to worry about it here is because the original function, the domain was not all reals.
So our restriction will be like
Okay. Yep. Okay. So let's do this next one. Okay, this one is a little bit harder to like try to figure out on your own. So I like to graph this one so we can see if it passes the vertical line test. I'm sorry, the horizontal line. Yeah. X over x minus 3. This one's tricky. So, do you think it passes the horizontal line test?
No. I don't think so. No, because they meet at one line.
Okay, so so this one, okay, so up here and down here there is no issue, right? It passes the horizontal line test. Now, in the middle, where you feel like it levels off, it never really becomes a horizontal line. There is always like a tiny little grade of it, like it's going up, 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 up a little bit, right? So it does pass the horizontal line test because it never really like becomes a flat line, okay? So this passes horizontal line test. Okay, so now we're going to solve for y. First, we replace this, then we swap. Okay, now, so far I haven't really done any math, I just swapped x and y. Now, to solve this for y, I'm going to put this over 1 and I'm going to cross multiply. All right, so cross multiply this way, y equals this way is this. Okay, so moving over here, y equals xy minus 3x. Okay, I'm gonna bring everything with the y to the same side. So y minus xy is equal to negative 3x. Factor out a y first. Okay. So y is negative 3x over 1 minus x. I need to solve for y, so I need to factor out a y. So I get this, then I need to subtract divide 1 minus x, 1 minus x. This is probably like the most complicated it'll get. Okay, yeah.
So always with fractions cross.
Yeah. And so here, this is going to be f inverse of x. In the bottom, you don't. So that's f inverse of x. Okay. And again, we're not going from like a square to a square root, so don't bother with the restriction. We're going to worry about those when it's a square and a square root. Okay? Yeah, because that's the only place where you add an arm or you subtract an arm and whatever. Okay? Yes.
So for the square root.
So
if you go like to the one, like the first one that we did. You got 0 to infinity. But did you get that like by drawing that line in the middle?
So what I did was this. Yeah. So I told myself. So since this is a square root versus a square, I initially draw the initial function. This is the square root. Then I say to myself, okay, this is technically a parabola, right?
Yeah.
But I only need half of the parabola. Okay, this, right? And so when you take away half of the parabola, what have you got left? You've got the region from 0 to infinity, so that's your domain. Okay? By doing this, you're actually saying, okay, x squared minus 6 is a parabola, but we don't want all of it. We only want from 0 to infinity this half. That's what you're saying. Okay? Okay, now, there is a special thing that happens with inverse functions, right? When you take compositions of inverse functions, right? There is a theorem, it's a rule, where it says, if two functions are inverses, right, then f of g of x is equal to x, g of f of x is equal to x. Okay, that sounds like a lot of gibberish, but here is what it says. Here's what practically you need to do. Whenever you see the words verify that f and g are inverses, this is what you have to do. Okay? So, verify that f and g are inverses, you want to split the work area into 2. Remember for the symmetry, we split into 3? The reason why we're so adamant about you doing that is because you need that skill in other things as well, right? So here, you split into 2. Now, you're going to do this every single time. When it says verify that they're inverses, you have to find f of g of x, and then you have to find g of f of x. This is why we taught you the lesson from before, okay? So, let's find f of g of x. The outside function is f of x. Now, if I want f of g of x, all the x's are going to be replaced by g of x's. So negative 5 times g of x, okay, plus 4. Now something magical will happen. These will cancel. So you have negative 4 minus x plus 4. Well, it's negative in parentheses. And now when you distribute, negative 4 plus x plus 4, which gives you what?
Just an X.
Just an x. Okay? It all goes away and you're left with an x. Now we're going to do g of f of x. Yeah. Because the top has a negative 5, the bottom has a positive 5. So only the 5s. Yeah. Now we're going to do g of f of x. The outer function is g of x. G of f of x is this. 4 minus, in parentheses, negative 5x plus 4 over 5. So now, okay, so we get, when you distribute 4 plus 5x minus 4 over 5. So take a minute now while we're doing this. Also, put your cell phones in your backpacks, please, while we're doing this. So let's see what we get here. The 4 minus 4 go away. You have 5x over 5. And what does that leave you with? X. So look at that. They are inverses of each other because we got x for g of f of x and f of g of x, and they're inverses. So now, it is magical because no matter how complex those functions are, if they're inverses, by law, they are required to behave in this way. It's supposed to go away and you get an x. Now, so somebody will ask me, what if it's 0, 0? Does that work? No. It just has to be x and x. Why x? Because, remember what we said at the very beginning, when you draw this line, y equals x, they're symmetric around that. So it's all tied to each other. Okay? So, let's do another one. Yes. Yes. So you'll show that you got x, you'll show that you got x, and then you say, yes, they are inverses. Yes.
Anything other than x for either of them or not?
Yep. It's like an all or nothing deal. So if for the first one you get like 3, given that you did it correctly, you can already stop. Okay? Okay. So f of g of x here. So f of x is x squared over 3 plus 7. F of g of x is this squared over 3 plus 7. Yeah? All right? G of x squared over 3 plus 7. What happens with the square and the square root? They cancel away. They go away. They cancel out. 3x minus 28 over 3 plus 7. So what happens here? Do they? No, they don't. So you can't cancel this and this because it's 3x minus something else. You can't because 28 doesn't divide by 3.
That's true.
Yeah. So it looks like this one just doesn't work.
Doesn't work.
No.
If you don't get X,
Yeah. And I really thought this was, and now I'm wondering if like I just did a typo in here, or you know what, it's okay, we'll just leave it. And it's I'm trying to think back to like 3 months ago when I wrote this or whatever. So it's okay, you know what, it's good that it worked out this way, because then you know that, you know, it doesn't work. Okay? Yeah. Yeah. Yes. And then each time. No. Okay, so here's what we're going to do though. Because I don't like leaving this like this. Let's change these to 4s.
Oh no!
No, just the 4s. Just the 3s to 4s. Just make the 3s into 4s. Here. Yeah. So here.
Oh, no, I get it.
You see that? You know. It would have been easier to change the 28 into 21, but it's okay. It's okay. This is like live math. Okay? Yeah. No, okay, so I'll yes, you're right.
Oh my god, the answer is X.
So, okay, so Yuval says it's X, and I believe her. So it's X. Okay? So the 4 comes out, and then you get X. So now what about G of f of X? Huh?
X minus 7 plus 7, and then the 4 here right there, and then it's X minus 7 plus 7, X minus 3.
Okay, okay, I apologize. I went over that a little quickly. Should we go back?
No, we're good.
You guys okay? Okay. So G of f of X, right? G of X is the square root of 4x minus 28. So G of f of X is equal to 4 times x, f of X, x squared over 4 plus 28. What the heck?
Plus 7.
Sorry, hang on one second. My pen is. Okay, one second. To the graph of this. Any questions before we move on? Okay. All right. Now, using the graph to do the inverse. Okay. Right? You can choose, I like to choose the ones at the corners. So just select a few corner points, interchange the x and the y coordinates, and then graph the new ones. So here, this is a good one. So that's -3, 0. This is a good one. It's on the corner, -2, 1, a -1. What's another one? This one,
6, -1,
1, -2. Okay. And then there is another one here, 6, -3. That's good enough. Okay. You basically, the more you do this, the better at it you'll become. But 4, I think, is a good number. 3 to 5 is a good number of points to do. Now you're going to interchange them. So just 0, -3, -1, -2. Don't mess with negatives. Just swap x and y. -2, 1, -3, 6. So let's graph them. 0, -3, -1, -2, -2, 1, -3, 6. Give it that same shape. And that is the inverse. Okay? And now this is all you have to do. If you do this, you've gotten full credit. But let's just see what happens if we do graph the line y equals x. Do you see how each of these points is a mirror image along that y equals x, right? Okay. So again, anything in red that I've done, you don't have to do it. I'm just doing it to illustrate something. Okay? You have to do what's in the purple and the blue. Okay. Last one. So let's see what are some good points here. 0, 3 is definitely a good one. 1, 4. What about -1, 2? -2, -5. Good. Ish, yeah, like don't go crazy. Like, you know, like the ones that you can be super precise, we're super precise, and then some, I understand there might be some that's like a little bit of a ballpark. Yeah. 1 +4, thank you. So now I get 3, 0. Oh, sorry, I got, this is -1, 2. So that's 2, -1. And -5, -2. So 3, 0, 4, 1, 2, -1, -5, -2. Huh? Okay, so the way it looks, do you see the original graph? When you also do the inverse, one thing is it's like a 90-degree rotation this way. So it's like you take this and flip it over. That's how it's going to look. So this, it's like lying on its side.
Should we extend the line past the
Not really, like this. Okay? Yeah. Okay, so, right? So do you see this one? Do you see this one, how it's like a little, like a little rest right over here? I did that one first, and then I kind of go like this, and I go like that. Okay? So that is section